Hello. Boo. Hello. Hello, hello. Hello, hello. Hello, hello. Oh, get out of the way. Out of the way. Charge it. Out of the way. Hello. How are we all doing today? Hello. Hello, hello. Everyone here? Not many people here, I don't think, today. That's alright. Have a small one, I suppose. That's always fun. Nice, close-knit, I guess. How's everyone been? Are people here? Are we ready for some maths? How are we doing? Oh no, my Christmas lights aren't on. Uh-oh. Let me go put them on. Oh, sorry, got some green tea. It's very hot. Hello. Hello, everyone. I'm gonna go turn my lights on. Here we are. See how much better that looks? So much better. How? Cool. How have we all been? How is everyone doing this fine Monday evening? Monday afternoon? Evening, afternoon? I guess that's up to the person, isn't it, I guess. How are we all doing? Excuse my green tea. It's very hot, as you can see from the steam billowing out of it. It's a lemon tea, actually. It's very nice. Who would have thought it? I think I said that last week, didn't I, about how much I've been into tea lately. Apologies for last week, my Wi-Fi going off. My Wi-Fi is very annoying. Goes off all the time. I'm very surprised it hasn't gone off before, actually, in a live stream. It's gone off. It normally goes off at least once or twice an hour. So I'm actually very surprised. So touch wood, doesn't happen again today. Fingers crossed. But if it goes off again, I do apologise. It will come on. It comes back on like a minute or so, and I'll just kind of come back like nothing happened. Hopefully, if you're all still there. Sip. Well, that's hot. Okie dokie then. Cool. How is everyone? Everyone's saying hello. How is everybody doing? We all happy? We all good? Still not many people in. Might wait a couple more minutes for people to arrive at the scene. You good? Good. Good. Fantastic. How is everyone looking forward to the Christmas holidays, or the December holidays? We don't celebrate Christmas. How are we all looking forward to those? They're in a couple of weeks for most people. Very exciting. Get 2 weeks off, I believe, don't you? Maybe 3 weeks. How long do you get off? 2 weeks? 3 weeks? One of those numbers. I'm going to take a week off. It's quite exciting. Looking forward to it. I'm doing good, thank you. I'm doing very well. I'm doing very, very well. What have I been up to today? I filmed some stuff, and then I had a lesson just then. We did a paper, which was quite fun. The CIE IGCSE spec. Not common, but quite interesting. Very different to the regular GCSE specifications. So it's nice to see what life is like for people that are on the IGCSE. It's always so different to those on the GCSE. I always forget what the differences are until they're right there. Hello, Lyrics Blue. How are you all doing? How is everyone? I think we're nearly there, so we'll wait until 10 past, which is 1 minute. We'll wait until then, and then we'll get started. It's going to be angles in parallel lines and circle theorems today, or as much as we can get done of them as we can, right? Because both of those are quite good, not good, quite big topics, what I should be saying. Quite big topics, so we'll get done as much as we can, and then leaving time to chat. I love a good chatter. You know me, love a good chatter. That's so hot. Oh. You can see the lemon there. Looks very lemony. I have a 2 mock tomorrow. Oh no. How are we feeling? Have you revised? Are we well rested? Are we feeling optimistic? That's what we should be feeling, hopefully. How are we feeling? Are we prepared? Are we prepped? Are we primed? How are you feeling? Waiting for the typing. Not prepared at all? But at least it's only a mock, right? If you're not prepared for this one, then, you can prepare for the next one. Next one being the actual one. in what? When is the actual one? When do they start? May? Spooky. Very close. Very, very, very close. Got a 7 in your maths mock. Well done. That is good. That is fab. Is 7 what you're aiming for? Are you aiming for higher? You're aiming for the top, top? Or is 7? Because 7 is great. 7 is really, really good. 7's fab. That's what I got. I got an A. But it's very different because obviously we had a very different specification to what you've got. But it's roughly what I got. Roughly. Basically off topic, I tried booking a tutor off the My Tutor thing. I had the free meeting. Oh, well, that's not good. Reach out to My Tutor Support because they're very good at My Tutor Support most of the time. So if you reach out to them, either like send them they'll have like a little chat thing that pop up on the bottom right. It's like a little blue like chat symbol. They're normally very quick on there, and they will be very quick to help you because obviously you want to give them money. so them message them and they'll help. They'll help you out. Hopefully your tutor goes well though. That'll be fun. Get to meet a new tutor. That'll be fun. I had the meeting yesterday. Yeah, don't worry, just message them. Actually, your tutor should be able to help you as well, unless they're a bit, unless if it's like, they're new, either or. But they should be able to figure out exactly why something's going wrong. They'll know. Like I have tutoring for many years on that platform, and every year the same problems. People struggle to send things off. It's always the same. So if you message your tutor, they should always be able to help as well as Samuel has put in the support at mytutor.co.uk. So if you don't want to speak to anyone, then you can always send an email, which I guess is still speaking to someone, but alas. Targets are 7 but want an 8 and a 9. Grand. Aim for the moon, aim for the top, might as well. If you fall short, at least 7's still a fantastic grade. GCSEs don't mean very much. I mean, it's nice to do well, isn't it, I suppose, but unless you want to go to like Oxbridge, then you'll probably never see GCSEs again. But aiming for the moon is very exciting. And then had a maths mock in June. Oh good. So I'll have a maths mock in June. Are you in year 10? That makes sense, yeah. So normally people have mocks like just when the year 11s finish, or when the hall starts opening up again. It's still in the exam setup. So they have year 10s in doing their mock exams. That's fun. See what else. Message the tutor. Screenshot what it says. Yeah, they'll be able to sort it, don't worry. And they'll either reach out to chat themselves, or they will know what the problem is. I'd imagine 9 times out of 10, like every time anyone messages me, I know what the problem is, like immediately. I know exactly what's wrong. So do not worry, they'll sort it, don't worry. Cool, shall we get started? I'm going to stop burning myself on my teeth. It's still so hot, you can see the steam, can't you? No, you can't, not really. Maybe I've hold up my glasses, you can roughly see it. It's fogged up my glasses. But anyway, shall we get started today? Let's have a look then. So let me change the slide so we can see it. Showtime, here we are. Angles in parallel lines and the circle theorems. Angles in parallel lines and the circle theorems. So angles in parallel lines is, so obviously circle theorems, they're just higher. Higher tier only. So if you're doing foundation, I do apologise. Half of this lesson you're not going to get much out of, apart from just maybe having a bit of fun, seeing what life is like for the higher students, having a bit of a fun to see just what maths is like for them. But angles in parallel lines, they're both on foundation and on the higher paper. Pretty much every time it comes on higher, it comes on foundation, It's that kind of a mid-tier topic. So let us get started. So can we remember any of... I seen a slide. You also seen a slide. We'll wait for my tutor to figure itself out. We'll wait for my tutor system to figure it out, right? But can we remember what any of the parallel line rules are? So if you see a question, it's like, okay, this is angles in parallel lines. What are my rules? It's 3 of them. A couple more as well. That's just general angle rules. But what are the 3 rules we have for angles in parallel lines? Can we remember while I try and figure out what my tutor's doing? Hello, my tutor. Are we awake today? Oh, that one's loaded. Okay. Okay, yes. Alternate angles are equal. They are indeed, yep. Alternate angles is definitely one. And what do they look like? Because alternate angles is the proper name for them. Well done. But what letter of the alphabet do they look like? Opposites are the same, yeah, perfect. Not quite an angle in parallel line rule, just an angle in general rules, opposite angles. Because they're ones that look like this. There's like X ones, you can get those anywhere. So those ones being the same. Absolutely right, they are indeed equal. And then what else have we got? Corresponding angles, absolutely right. What letters do they look like? Corresponding angles. And then, so yeah, alternate angles are indeed like a Z. So we've got, for alternate, either a right way around Z, which is right where my face is. Let me move it down here. So we've either got this kind of Z here, where these are the parallel lines. So then the corners of the Z are the same. Or it can also be kind of like a backward Z as well. It doesn't have to be literacy correct Doesn't make any sense, does it? But oh well. These ones here are also equal. Perfect. And then we've got corresponding being an F. Absolutely right, it is indeed. So then we've got that there and that there. And then which angles are the same in corresponding angles? If these are your parallel lines, which angles are the same? If I label them, let's call that one 1, that's 2, that's 3, and that's 4. Which angles are the same in corresponding angles? So that's 1, the one up here. That's 2, the top corner. 3 is like bottom corner there. 4 is underneath. Let's have a look, see what we've got. While I figure out why this is not, why is it not loading? Okay. Okay. Let's have a look then. 2 and 4, 4 and 2. Absolutely right, it is indeed. So it's always I would call it like the corners underneath the sticks are the same. So absolutely right. So like this one, this is underneath the top stick, and this one underneath the bottom stick. It's always the underneaths of the sticks that are the same. Perfect. Then there's one more that we've all missed. One more. If you give you a clue, it's this one. The angles aren't the same. They are, well, they add to 180 degrees. So you have a little think. That's your clue. I sip my green tea. That's your clue. So there's one more. Also begins with a C. So we had corresponding that we've had. One more that begins with a C. That's, you know, they add it to 180 degrees. They're not the same. Let you have a little think. While I maybe delete all this and try and upload the PowerPoint again. Perfect, mate. Absolutely right. Co-interior. This, I'm going to go back to my face again. 1 second. I don't want to show you all my files while I try and upload this again. Is indeed co-interior. May is absolutely right. So you may not learn that one as its own circle theorem, or not circle theorem, you may not learn that as its own rule. You may just kind of like learn to spot it because it looks sort of like an F angle, but sometimes it's helpful to know just that one on its own so that you can use it accordingly. So co-interior is ones that look like a C, so like this, which you'll notice kind of like the top part of an F, like that, but ones that look like a C. So this one and this one add to 180 degrees. So you can also get it by kind of saying that these two are equal and then just like angles on a straight line. That's also something you can do. But it's sometimes easier to learn this C angle, this co-interior, because if you're ever not given the rest of this, it's hard to be able to spot that you can put a stick there and call it an F angle. That's kind of a tricky thing to spot. So knowing that just a C angle on its own adds 180 degrees, also rather good. Okay, so those are the three. So we've got co-interior, that's this one. So co-interior. And then we have got this one, which is alternate. And then those were two of the same. And then we've got this one, which is corresponding. Okay, and there we are. And then let's go to the first question then, hoping that it's loaded. There we are. Grand. Okay, cool. So those are your three. So we've got Z angles, alternate, F angles, corresponding, C angles, co-interior. So here is a question. I'll make it bigger. Do not worry. I hear you all getting upset at me. I will make it much larger than what it currently is so we can see it a little bit better. So this is from the November 2017 paper 1 from Edexcel. It was 4 marks. If you're doing AQA or OCR, do not fret because they're all the same. Do not worry. AQA is a bit more wordy than Edexcel, but Edexcel and AQA for this kind of topic, very similar. You can't really tell the difference normally. Same with OCR. But anyway then, so ABCD is a parallelogram. EDC is a straight line. F is the point on AD, so that's BFE is a straight line. Angle EFD is 35. Angle DCB is 75. Show that angle ABF is 70. Give a reason for each stage of your working. Okay. So possibly, do a quick sketch of it if you want to be able to see it properly, or, I don't know, just have a little go, see what rules you can spot. With this kind of thing, what I always suggest is just put down whatever angles you can find. Literally any angle you can find, put that down, right? And it doesn't matter if it's related to the angle you're actually trying to find or not. If you can find an angle, if you can spot a rule that you can use, put that rule down, and then job's a good one. It'll help all build this picture, right? So you may find one angle, which then leads you to find another, which will then lead you to another, then it'll actually lead you to the answer. You may not be able to see exactly the steps that you take to get there, but just get down anything you can and go from there. So, either let you guys figure it out, see if you can, well, show that it's 70, like what are the steps, or just tell me anything you can see, any angle fact that we can see. What can we spot? What can we spot? I'm also saying that my tutor's reading, like I'm using their platform for their whiteboard for this video, but I'm seeing that they're reading it at 2 bars. Ew. So I don't know if it's delaying or anything. Hopefully not. I also don't know if it's going to shut off again. Again, hopefully not, touch wood, that does not happen. But if it does, I do apologise. I'll be back very shortly if it does. Also get a new Wi-Fi, which is good. 15th, new Wi-Fi time. But anyway, that'll be ended after all the live streams, which is a shame, but oh well. Let's have a look then to angle AFB is 35, because it's vertically opposite. Absolutely right, it is indeed. So this guy here is indeed 35. 35. And then Michaela, I'm seeing this, I've already made it bigger. Making it bigger than this, I don't know if you're like delayed or anything. But I shall wait for your response on that one. BAF is 75 because they're opposite angle of a parallelogram. Yes, is indeed perfect. Absolutely. Absolutely right, Rahaf. Absolutely. It's another basic angle fact. Well, not really basic. Kind of a little bit tricky, that one, to remember. Not as common as like angles on a straight line and such. But yeah, that is indeed that. And then we are trying to find this angle here, for those who don't know. ABF, which is this one here. That's what we're trying to find. Okay, let's have a look then. Yes, where have we got 180 from? I know that you know, but just so that everyone else is aware, where have you got 180 from? Where's 180 come into it? I know that you know, but just so that everyone else can know as well, just in case they don't. Yeah, angles of a triangle, easy peasy, grand. So angle of a triangle then add up to 180 degrees. So then absolutely right, so you add them all up, 75 plus 35, which is 110, and then 180, take away 110 is indeed 70 degrees. Et voila. And then give a reason for each stage of your working. So every angle that you've done that's led you to that point, you need to write about it. So what I would say for this, I won't do all of them all the time, because I know it gets a bit tedious, doesn't it, seeing the same stuff over and over again. But what I would put for this is that, so angle AFB is 35 degrees as opposite angles are equal. So you don't need very much, you don't really even need full sentences. Angles are equal. That'd be it for that. And then angle BAF is 75 as opposite angles in a parallelogram. Parallelogram, can't spell, are equal. And then angles in a triangle will be your last point. I can't really fit it in. I'll write it over here. So then angle ABF equals 70 as angles in a triangle at 180. And there we go. Et voila. Cool beans. Grand. Any questions about any of that? How are we all feeling about that one? That one's not too bad, right? We like that one. Question 3 on the high paper. So about question 22 on the foundation paper, so right near the end. How are we all feeling on that one? We all happy? We all feeling good? That was okay? Good. Let's just move on then. If anyone has any questions, speak now or forever hold your peace. Just move on. Oh no. My tutor, what are you doing? What's happening, my tutor? Why are you not working right now? I need you to work right now, please. Okay. So bear with me one moment because it appears my slides are not loading in on my tutor today. It seems that my tutor decided doesn't want them today. It's not feeling like showing my slides. Doesn't want nothing to do with them. So let me see if I show you this or anything dodgy on it. I don't know if you could see my email. Do it dead quick. Oh no, you shouldn't be able to, but I might be able to. Just give me 1 second. I'm going to try and screenshot it in. Maybe that'll work, because my tutor doesn't know he doesn't want to play today. It's not feeling like playing today, unfortunately. It was working earlier. Oh, there we go. Can you see that? I can see that. Let me double check. I can't see what you can see yet. Yeah, you can see that. Grand. Okie dokie. And my tutor, I don't know. Michael might know. Samuel. Gosh, sorry. Got your name wrong. Samuel might know. But I do not. So they did them last year, so I can't imagine them not doing them again this year. But again, I may stand corrected. I'm not overly sure. I didn't do one last year. I didn't write any. So, I don't know. I'm not sure. Maybe that's a question for, actually, who could you ask? Like the online, I guess they haven't really decided yet, because obviously next summer is many moons away, I suppose. Maybe they haven't decided yet. Maybe they need to still reassess what happened last summer. But anyway, here's the next question. November 2018, paper 2, Edexcel, 4 marks. Again, question 3 is on a different paper. So we've then got this one here. So BEG is a triangle. ABC and DEF have parallel lines. How good. Work out the size of angle X. Give a reason for each stage of your working. Et voila. So there we are. Let you have a little look at that. Yeah, I didn't mean to throw you under the bus there, Samuel. If you don't know, I do apologise. I didn't mean to throw you under the bus and drag you in to talk. I don't know. Maybe he works on my tutor in more regard than I do, so he might know more than I will. But I'm not overly sure. I don't know. I didn't write any. I didn't have much to do with it last year, so I don't have much to do with it this year either. But who knows? Who knows? I don't think they do yet either, but maybe. Yeah, something in the works. Maybe something secret's planned. I don't know. Did you go to one last year, Mikhail? Don't know if they're any good or not. Hopefully, I bet they were. My teachers are very good, like myself, very good. But which one did you go to? Maybe not with which tutor, but like what in general? Was it like maths, science, English? I didn't know much about them. So a couple of my friends ran some, but French and French, fun. But that was a nice mixture. Sounds exciting. Fun. Yeah, I think it was like, because what we're talking about now, those group sessions, essentially what happened last summer was they did like a whole bunch. So they had like different tutors running like different subject specific, like kind of like intense courses. Not really intensive, but like you pay for like a set number of like 5 lessons or so, and they'd have like a lesson plan of what was happening on each. It's kind of like not really like a group thing, but like you'd be there and it'd be like 3 or 4 other people, I think. Group courses kind of thing. So you get like the same tuition as you would get kind of with a one-to-one, but in just like a group setting, so a bit cheaper. So yeah, I think it was a good initiative, but I guess we'll see what happens this year. I don't know. Again, Samuel might know, but he may not, so he may not wish to speak on the matter if he doesn't know. But anyway, so let's have a look then. So we've got one answer, we've got 160 degrees. See if anyone else wants to pipe up, but I'll see if you're right. Let me double check while I'm at it. Let's have a little look, see. have a look. Not quite what I got, but I did it very quickly in my head with the calculator, so I didn't write anything down. So maybe not, I guess we'll see. Actually, let's go through it now. Why not? Giving people plenty of chances. Let's go through it. So, what did you spot first, Rehan? What did you do first to get 60? What did we spot? Or anyone. What can anyone see, first off? DE is a straight line, and straight lines are 180 degrees. Yeah, perfect. So DEF is indeed a straight line. Perfect. So then we're going to have to do 110, that's the right yellow lyrics blue, plus 25. And then whatever's left has to get it to 180. So we're going to do 110 plus 25, which is what, 135. And then 180, take 135, and that gives you, whatever get that gives you, what, 65 or so? 180 minus 135, oh, 45. There we are, perfect. Cool, and then, let's see what else. So that's then 45. How exciting. And then, let's have a little look. See, what else can we do from there? I wonder. Any other ideas? A little bit trickier, this one, huh? Have a little think. What else can we spot? Give you one more second to write it out. If I don't get any responses, I'll just tell you. Angle ABE is 70 degrees. Where did we get that one from? And it is alternate, it is indeed. If that was there, but it is indeed. So alternate, because if we may be able to see, this guy here is a Z. So 45 plus 25, let me just double check, 45 plus 25 is indeed 70. So then this guy here, because these guys here are going to be equal to it, is indeed a 70. Cool, okie dokie. And then, so careful, so 25 is an alternate to anything because this does look a bit like a Z here, very nearly. But because it has to be, the Z has to be, top and bottom has to be parallel lines. There we are. Or you could use the C thing, absolutely right, the co-interior, absolutely, absolutely. This would also work because 180 take away 110 is 70. So I also use co-interior. Everyone's easiest because this is indeed, let me get my colours out. This is indeed co-interior here, this C. Oop. So then this one plus this one does indeed give us 70. There, 180. Cool, and then we need to do next step. So what next from here? Yep, 75 plus 35. Take that again from 180 to find this dude in the middle here. Put that straight line. This dude in the middle. So then we do 180 minus 70 minus 35. And that does indeed give us 75. And then how do we get x? Last step. How do we get x? How do we get x? Yep, 45 plus 25. Or 75 plus 45, I should say, not 25. What do we do with that angle then? Yeah, perfect. And take it from 180 because it's an angle in a triangle. This guy here is a triangle. So then that gives us then 60 degrees. And there we have it. Voila. So yeah, they can get quite tough, can't they? There's a lot of stuff to do here, a lot of stuff going on. But it is worth 4 marks, so I mean, not too bad, I guess. Just like, can you spot it or not? That's the main thing with these. You can learn all the rules, like all day, every day. When age is learning all the rules. If you can't spot it on the day, then sucks, doesn't it? But I guess just to get to practice, isn't it? Just get to practicing them over and over and over and over and over and over and over again, and seeing, okay, let me find anything I can, and then going from there. Cool, then how long we got? Got about 50 minutes or so. I always run over those. So I don't. We move on. Look at the circle theorems. I think that sounds good. It's still not loading. How odd. Because it still marked it as being loaded. Oh well. What can you do? Nothing much. So let me then grab circle theorem stuff. So circle theorems, higher only. So if you're doing foundation, do not worry. They may seem alarming, but you don't need to do them, so do not worry. If you're doing the IGCSE, these are not all of them. These are only the ones for the GCSE. You have an extra one, which I'm not going to go through today, but you have an extra one. So don't take this as a definitive list if you're doing the IGCSE. This is only the definitive list for the GCSE. So if you're doing IGCSE, it is different. But anyway, these are all of the circle theorems. Oops, wrong way. Ta-da! There we are. So we got this one. So the angle in a semicircle forms a right angle triangle with a circumference. That's that one. With this one, important to note that this line has to be the diameter and this has to meet at the circumference. That's one thing. Then with this one, this angle here has to be like between like the legs of the like arrowhead. It can't be around this way. That is wrong. Sometimes what they do. And then heart is double what this one is. So angle at the circumference is double the angle at the center. Then got this one. The angles in the same segments from a common chord are equal, also known as the bow tie rule. As you can see here, this little blue line, this dashed line here, is the chord that both of these angles are coming off of. And there we are. So these ones would both be the same. These angles down here would also be the same. Let me use a different colour than that one actually. These ones down here would also be the same, with the common chord being this chord there. Those two would also be the same, with this being the common chord. And then we've got angles in a cyclic or cyclic, whichever one you want to say, cyclic quadrilateral, always adding to 180 degrees. So trick with this one is be careful. Make sure all four corners have to be on the circumference. If they are not, if you've got something that looks very rectangular, but the corners are not on the circumference, they are trying to trick you. Do not fall for it. All four of these corners has to be on the circumference, which may need it to look a bit funky. So it could look very not like a cyclic quadrilateral. It could look very much like just a weird looking shape like this. So 1, 2, 3. Doing that's a bit quirky. 4. That's like not really like a quadrilateral. I guess it is, but more like a kite than like a classical rectangle, right? So they have to all look like this. They could look something like this too. Have to all be on the circumference. And then you've got the right angle ones. This one is the most common. This one comes up all the time. Tangent meets a radius at 90 degrees. That's that one. And then this one I have never seen once in my life come up in an exam. But it's one all the same, so you never know. This year could be its year. This year could be the year it makes an appearance. Who knows? But it's never come up before, so will it come again? Who knows? Who knows? Anyway then, so this one is if you kind of cut the midpoint of a chord with the radius of a 90 degree angle. So this here, this is the chord, and if you manage to get it dead in the center and draw that line to the center of the circle, then that'll be 90 degrees. There we are. And then again, never come up before, so who knows if it ever will. And then we've got this one here, which is one everyone knows and loves, the alternate segment theorem. So with this one, the angles are opposite each other. So this one, or alternate with each other, this one and this one. The way I remember it, because it's slightly different to parallel lines, as you may notice. In parallel lines, the ones that would be alternate would be like this one with this one, this y with this x. But where I think about it is it's circle theorems, so it's more awkward, so it's going to be the next one. That's what I always think. So I think so that's when I see it. So I see it, and I think, okay, this looks like it could be an alternate segment theorem question. So it would be that one, but it's not. It's awkward, so it's that one. Right? Does that make sense? And that's all the rules. There we are. There we are. We can hear that my partner's coming in from work. But there we are. Cool. Do we all have any questions? How are we feeling about circle theorems? Having gazed upon them for the past couple of minutes or so, how do we feel about the circle theorems? Do we remember all of these things? Do they all ring a bell? Have we seen these all before? Fab, yeah, good. Good, 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 good. Is there any you would like me to go through in more detail? Is there any of these? Let's label them actually. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7. Is there any you'd like me to go through in more detail? I know it can be a bit rambly. I talk very quickly. A negative trait of mine. But is there any of these you'd like me to go through again? Or are we ready to do some questions? Up to you guys. What do you fancy? 7? Cool. Go through question 7 again. So this is the alternate segment theorem. So with this one, the way you always spot it is it's always going to be a tangent with a triangle. That's the way to spot it, a tangent with a triangle. So let me draw a circle. So if you have a tangent, it's more likely either going to be number 5 or number 7. So keep an eye out. Okay, I have a tangent, therefore do I have a radius or do I have a triangle? Sometimes both, as a matter of fact. But do I have a tangent or a radius or do I have a triangle? If you have a triangle, it is the alternate segment theorem. It could be any type of triangle. It could look like something like this. Okay, so with that, you got a tangent, you got a triangle. What I always do is the one, like the corner here, so where the radius, or the tangent, sorry, okay, my words mixed up, don't I? The tangent with the first line of the triangle as it goes up will always be alternates. But remember, it's not parallel lines, it's more awkward than parallel lines. So it's like, so it would be this angle here, but it's not, it's the next one. So this one and that one are the same. Same thing works for the other side as well. So this angle here, so the one with the tangent with the other line of the triangle is the same. So it would be, alternate would be this one if it was parallel lines, but it's not. So it's the next one. So then this one is the same. So this one with this one, and then this one with this one. And that is the alternate segment theorem. And there we are. And then next we've got 2 and 3. So essentially 2 and 3 are kind of like another kind of spotting game, right? So in number 2, you're just looking for an arrow ahead, which is this shape here. Will always look like this. You'll have all points on the circumference apart from this one at the center, and the angle at the center is always double the angle at the circumference, and it always looks just like this. And then with number 3, it'll either look like this without this line here, so just like a bow tie floating in space, or it will have these lines on it. And then all it means is that the ones on the same side of this chord are equal, that one and that one, and also this one and this one, so on the same side versus this chord here. Essentially the ones that are like next to each other, essentially going from the chord. And there we are, that is that. Let's do a question then. I think, are we all happy? How are we feeling about this? Feeling good? Hope so. Hooping the hoop so. Anyway, let's move on. Let's see what we got. Nothing. Nothing we have. Let me grab the next question. I don't know why it's not loading today. It's rather upsetting, not going to lie, but that's okay. Can't have everything in life, can we, I suppose? Can't have everything work all the time. Okay, then. So, this question here then. Oop, there we are. So, we've got November 2017, paper 3H from AQA. Let me zoom in a little bit so we can see it. Question 19, 2 marks. Let me zoom in a little bit so we can see it a bit better. There we are. So not drawn accurately, so if you're whipping out your protractor to go on screen, it's not going to work. The ABC are points on a circle. CD is a tangent to the circle. I wonder which circle theorems tangents relate to. Write down the size of angle X. Give a reason for your answer. So what are we thinking about this one? Only 2 marks, so not much work. Have a little think. Oops, sorry, my spoon is making a little noise. Let me take these out actually, now that I think about it. It's been brewing for quite a while, nearly 45 minutes. Let me take my spoon out. And there we are. Good question, Mikhail. What is a tangent? So a tangent is a line that touches the circle once and once only. Like this line here. This is the line that touches the circle once and will never touch it again, right? So like a line like this would not be a tangent because it cuts it here and here. But a line like this then would be a tangent because it only touches it there. So a tangent is a line that only touches it once. And there we are, that's tangents. Well done. And then let's have a little look-see. Perfect. So then we've got some good answers in the chat here. Good answers. So yeah, it's indeed the alternate segment theorem. Is indeed, because we've got a tangent and a triangle. Therefore, it will be the alternate segment theorem. So this angle here is going to be alternate with not this one because it's awkward. It's going to be this one instead, 65 degrees. The reason for that is the alternate segments. Oop, that's not spelled segments. What is it? Segments theorem. Ta-da! And there we are. Cool. Easy peasy. Well, I guess easy peasy is on the eye of the beholder, I suppose. But how do we feel about that one? Are we all happy? Are we all making sense? Anybody confusion? Yes. If those are parallel, if these are parallel, then yes. But they won't put a circle in it. That'll just be confusing because currently these are not parallel, as you can see. This one's like off to the side, so a bit bent, like off to the side. So they would meet somewhere down here. But yes, if it was parallel lines, then it wouldn't be 60. But they won't put a circle and parallel lines together. They'll clash. But there we are. Cool. Okay then. Moving on. Good question. Moving on to nothing. I always forget. Keep forgetting this is not working. So then we've got November 2020, paper 1. Where are we? Can't see it yet, but here we are. So November 2020 from edXL. It was a good one, this one. I quite liked this one. So let me make it a bit bigger so we can all see. There we are. We can all see that, hopefully. Question 14, so like halfway through the paper, well actually no, a bit further on through the paper, like kind of 2/3 maybe. So point B, D, E and F lie on a circle. Find the size of angle ABD. You must give a reason for each stage of your working, which I haven't been doing, but essentially it's just listing out the rules. Essentially that's all. Listing out the rules is all. Let you guys have a little thinker about this one. Has a little think. What are we feeling about this one? What's the difference between all three examples? Is it because there's a different content in each one? Not really different content. It's just a case of, well, they're all pretty much charities. So it depends on which school, what their teachers like better. So it tends to be the decision of like the head of maths of your school department, whichever one they prefer, whichever one they're used to teaching. It tends to be that one. But it's not the case for everyone. It's just a case of that's what it normally goes. So there's not much different between them. The IGCSE, it's just, I don't know, some people like that better. Tends to be more private schools through the IGCSE, not always, but tends to be in this country, and then countries abroad, like schools in like Dubai and the States, and like British schools that are like elsewhere in different countries, they tend to do the IGCSE. And that's like the decision between like CIE and edXL, but edXL is more popular than CIE. And then what else is there? An AQA, OCR, and edXL. There's very little difference between them. Very little. It just depends on which one the school wants to teach. OCR is less popular, and then edXL is probably the most popular. Because it's a bit easier to teach for, I think, edXL. Because edXL there's more content, and the content is, well, I wouldn't say that actually. No, not much content. Content is the same in all of them, pretty much. But edXL, the questions are harder, but it's easier to understand what they're asking, if that makes sense. There's not like weird wordy questions, whereas with AQA the questions are more wordy, but they're also often a little bit easier. So it's kind of a hurdle to get over, like what are they actually asking me to do here. But once you've got over that hurdle and you know what they're asking, it tends to be quite straightforward. So AQA is exactly like AQA's grade boundary has to be a lot higher than edXL. edXL does have like justify quantifiably harder papers, but they're a bit easier to kind of digest, I think. Easier to like get better at with practice, whereas AQA kind of up to their luck. Like it's like a luck game with whether you kind of understand what they're saying or not. Sometimes I have actually no idea what they're talking about with some of their questions. Even I've got a degree in engineering, can't figure out what they're trying to say sometimes. But that's the only difference between them all. Depends on which one your teachers like better, whether you do AQA or edXL. So yeah, not much difference. If you do fancy, like if you run out of papers from your exam board, like if you're doing Edexcel, do AQA papers. It's not much different. Like with the sciences, don't do that. Because the sciences do have vastly different content between them. They're very different. Different keywords, different content, different everything. But with the maths, you can do whatever you want, essentially. Try an Edexcel paper in AQA. Or try an AQA paper doing math if you're doing Excel, because it's very different. So chances are you're being taught a certain way to like answer a certain type of question. So seeing maths from a different perspective sometimes helps, like with Edexcel, particularly, which is quite nice. But there we are. Cool. Let's have a go then. You're stuck. That's okay. Yeah, it's tricky. It's tricky, this one, isn't it? It's quite tough. So A, B, D, E, and F are in a circle. A, B, C is a tangent. A tangent. What does a tangent mean? Who knows? Find the sides of an angle, ABD, or of the angle, ABD. You must give a reason for each stage of your working. So, I am seeing a tangent. I am also seeing a triangle in this circle. Doesn't matter, there's also something else strapped in the bottom of it. That doesn't matter. But I'm seeing a tangent with a triangle. So what circle theorem is that? Please tell me. What circle theorem is that? Tangent with a triangle. Who is that? Which circle theorem? Anyone, any ideas? Which circle theorem is that? Yeah, the one with alternate angles, yeah. So the alternate segments theorem is indeed alternate segments theorem. Perfect. So I know that this one is going to be 40 degrees, this angle here. Let me draw it out and let me put a highlighter. So this one here, it would be that one if it was parallel lines, but it's not because it's awkward, so it's this one. So we know that then this angle here is 40 degrees. We also know that these ones here are the same. Let me get a different colour highlighter. That these ones here are also the same. Not that one, it's awkward, so this one. So then this one and this one are the same. And actually this one, ABD, is what we're trying to find, this guy here. So we're trying to find this guy. And it's also the same as this one. So if we find this one, we've also got it. Okay, presto. So let's then continue on from there. So what else can we do? I wonder. So let's think then. So I'll give you a clue. What type of shape is this that I'm drawing right now in red pen? What type of shape is that? How many sides does it have? I wonder. I wonder if I should count them and see what it has. Quadrilateral is indeed. And all 4 points are touching the circumference, therefore it is a cyclic quadrilateral. And what do we know about cyclic quadrilaterals? What do we know about those? Cyclic quadrilaterals. Give me a clue. Let's see with the opposite angles. They add to something. So 180, yeah. So yeah, see all your angles in chats, don't we? We'll figure it out in a second which one it's going to be. So opposite angles add to 180 degrees. So these ones we don't really know because it's got this like extra weird triangle-y bit here. So we don't really care about those, but we can now know that this one opposite here, so this 100 is opposite, that's my straight line. So this 100 here is going to be this one here, right? So then this one plus this one, that's going to be then, what are we? 80 degrees, right? Because 100 plus 80 is 180. And then, this is a triangle or this is a straight line. Either or will get you the right answer. So then let's add them up. 40 plus 80, 120. And then 120, 180 minus 120 is 160. Oh, just 60. 60 degrees. So then that is then 60 degrees. Or this one is then 60 degrees. They're the same. Either or. Cool. Ta-da! There we are. How do we feel about that? How are we feeling? Tricky. They're tough for circle theorems, aren't they? They're pretty tough. They're not easy. Not easy questions. They are quite difficult. But how do we feel? Now that you've seen it, you've had time to digest it, Yeah, it looks harder than it is. Yeah, it does. It's just a case of spotting it. Once you spot it, so if someone tells you what circle theorem it is, it's easy. It's just a case of being able to spot that, get over the initial hurdle of actually spotting it. And that's the tricky thing. So you can learn all the circle theorems and that'll do you good, but actually be able to spot it, practicing it over and over and over again, spotting all these different rules will definitely help in the long run. Very confused? That's okay. These questions are confusing. That's what they're made to be. That's what they're designed to be, Mikhail, so you're not wrong there. So I'll give you a rundown, give you another brief overview of what we did. So I'll kind of show you like the quickest route to get there. If we spotted it all without having to like go through any of it. Let me get rid of some of this highlights. Oop. Okay, alright. Didn't mean to do that quite, but oh well. Let me re-get it up again. Actually, I think I should be able to just have it up here, yeah. Let me make it a bit bigger again so we can see it all. There we go. Okie dokie. Right then, so what you can spot first is that this is a cyclic quadrilateral. So this is a quadrilateral here and here. So it's still too small. I've made it bigger still. I've made it bigger again. Can't really think I can really make it much bigger than this. It's like normal. It's almost half the screen. Like still too small? Anyone else think it's too small? Anyone else think it's okay? Oh, just kidding. Of course. Okay, thank you very much. Thank you, my guy. Anyway, moving on. So, this is a cyclic quadrilateral. So, as we know about those, as we should know, opposite angles in a cyclic quadrilateral add up to 180 degrees. So, this angle here plus this angle here is 180. Therefore, this guy here must be 80 degrees. Now, you got me good. 80 degrees. And then, may not help very much. See you later, have a good one. Have a good evening. Have fun in English. So then this one is 80 degrees. So then it might not seem like it helps as much, but it does actually, as a matter of fact, because we can kind of figure some other stuff out there, because we now know this is a triangle, this guy here, right? This guy here is a triangle. This one with this one. Oopsie daisy. This one with this one with this one is a triangle. This like pinky one, should probably show in a different colour, but this pink one here is a triangle. Angles in a triangle, 180 degrees. So 180 minus 80 minus 40, that's 60 degrees. This one here. And then we were trying to find this angle, this one here. Where are we? ABD, which is this guy. And we know that these two are alternates. This one with this one. So this 60 and this one are alternate, so that one is also 60 degrees. Hopefully that makes a bit more sense to you. And that all the kind of filler in between, all the gaps in my speaking. But there we are. So, cyclic quadrilaterals, angles in a triangle, alternate segment theorem. Those are the three rules that we've used in this question. Cyclic, angles in a triangle, and alternate segment theorem. There we are. How do we feel at this point? How do we feel? We happy? We feeling good? We going strong? We still with us? We giving up? Fun times. Actually, I'm due to finish on time today. Who would have thought it? Who would have believed it? We. Grand. Cool. Okie dokie then. Any last minute questions? Because that's all the maths done for today. We'll call it there. If you do want any more practice, Maths Genie have some very good circle theorem questions. They're very handy. Or just have a flick through some past papers. They'll be them. They're in like pretty much every other paper. So flick through, you'll find a couple. So yeah, there we are. Cool. Any last minute questions before we wrap up for the evening, so I can go off and go teach some more stuff? Don't know what I've got tonight. Got maths and chemistry, I think, tonight. Depends on what he wants to do. Yeah, go around. Any last minute questions before we wrap up? What is your questions? I'll hang around for a minute. No more maths. If you do wish to leave, feel free. Or you can hear me chatter. If anyone has any questions. Then if Mikhail says he has a question, he's typing it out. I do not know. That's maybe trolling me again. I do not know either. Now I don't trust you. See? Now I don't trust you. So there we are. But, okay. If you do wish to leave, hope you have a lovely evening. Have a lovely rest of your night. Rest of your night. And I shall see you next week. If you pranked me, so that's my reward. A reward is, well, not getting banned. I could ban you. I could, but I will not. I've already done Pythagoras theorem, Davina. That was week... Let me have a look. See. It was one of these weeks. It was one of these days. I'll show you exactly which week it was. Let me find it. I've got it all on a spreadsheet somewhere. I've got it all on a spreadsheet. I'll tell you exactly which week it was. They're all recorded, so all these sessions you can watch them all back on YouTube. It'll be uploaded with it's uploaded like without the chat, like right away, but with the chat normally uploaded like tomorrow or something. When they tell it to. So trigonometry was done on week 3. So week 3 will have been, which day will that have been? Week 3. I can't believe it's already week 9. How crazy is that? Doing this for 9 weeks. Never would have thought that. So the first week was the 10th of October, and then week 3. So we did Pythagoras theorem on the 24th of October. So we did that, 24th of October. So they're not every day, they are every Monday at 5 o'clock. So I am Olivia, I do maths on Mondays at 5. And then we've got Fliss, who does coding on Tuesdays at 5. Same channel, just different streamer pops up instead of me, it'll be her. And then you've got Professor NK, or Nketia, who does study skills. And I believe he did some chemistry last week as well, who does Thursdays at 5. So I've got Nketia, who does Thursdays at 5, Fliss, who does codings at Tuesday at 5, and then me, who does maths on Mondays at 5. There we are. Cool then. If we're all happy then, I'm going to leave you all to your evenings. Have a lovely rest of your evening, guys, and I will see you all next week. So hopefully I'll see you all then. Bye. Other science? I think Nketia did science last week. So not science from me, but science from Nketia last week. He did chemistry, but it probably won't normally be science video. I think he just did that to go through like exam paper questions. I think that's what was the topic he was doing last time. But it's not quite from us. Science will probably, maybe one day. Used to know, maybe one day. But not as of right now, unfortunately. But anyway, I'll let you all go. Have a lovely rest of your night, and I'll see you all next week. Bye. Bye-bye. Bye-bye. Bye-bye.